This video is one of a series exploring the different ways that we work with significant figures in chemistry. The introductory video, Significant Figures and Uncertainty, is one you want to make sure you've watched before you start this one, because I'm going to assume, as I talk about this, that you know how to figure out how many significant figures there are in a measurement. So, when you're adding and subtracting measurements, we determine the uncertainty in each measurement, and then we identify which measurement has the largest uncertainty, and then the answer of that calculation has to have the same uncertainty. So let's walk through one of these together while we're looking at these directions. So let's say I had 100, and I wanted to add 90.2 to it. Now, if I was in a math class, then we would know that the answer was 190.2. But in chemistry, we know that these numbers are measurements and that measurements have uncertainty. And the uncertainty is located in the last significant figure. And so when we add two things together, we can't have our answer show up with more certainty than our measurements did, because then we'd be lying, and that's kind of frowned upon in science, among other places. So I'm going to check my first number here, and I see that my last significant figure, and my only significant figure, is in the 100th place. So therefore, my uncertainty is plus or minus 100. Now, this isn't a great measurement, right? If you're measuring 100 and your uncertainty is 100, it's not a great measurement. So hopefully we'd make better measurements. But for the sake of illustration, in this second measurement, my last significant figure is right here. It's the 2. And that is in the 10th place. So my uncertainty is plus or minus 0.1. Now, when we look at these two numbers, 100 is clearly much larger than 0.1. So my answer has to have the same uncertainty as the measurement with the largest uncertainty. So 100 was my largest uncertainty, so my answer has to have an uncertainty of plus or minus 100. Well, it doesn't right now. To have an uncertainty of plus or minus 100, my last significant figure would have to be in the 100th spot, which is right here. So I look to my next spot and see there's a 9 there. So this number becomes 200. Let's do some more examples. Let's take 0.01040 and add 0.013. Now notice I'm rewriting this and I'm lining up the decimal places, because that's going to help me. One shortcut to this process, especially when you're dealing with numbers smaller than 1, is to count decimal places. And the smallest number of decimal places is going to relate to your largest uncertainty. But for consistency's sake here, let's take the uncertainty route for right now. So at my top number, I have my last significant figure in this decimal place. So that means my uncertainty is plus or minus 0.00001, because 1, 2, 3, 4, 5, 5 decimal places out, 1, 2, 3, 4, 5, 5 decimal places out, that's where my uncertainty is. Plus or minus 0.013, my uncertainty is plus or minus 0.001, because my last significant figure was in that decimal place. Now, 0.001 is larger than 0.00001, so my answer has to have this uncertainty. When I add these two numbers together, 0.01040 plus 0.013, I get 0.0234. That doesn't have an uncertainty of 0.001, because 0.001 would mean my last significant figure was in the decimal place where the 3 is. So I need to drop that 4, and my answer becomes 0.023. Now I have 3030, and I'm going to subtract, I'm going to subtract a big number. Let's see, 00921, which is going to give me a negative number. Let's talk uncertainties. 3030 has its last significant figure in this 3 here. That's in the tens place, so I have plus or minus 10 as my uncertainty. 12,900 has its last significant figure in the 9. That's in the 100 spot, so that is an uncertainty of plus or minus 100. 100 is larger than 10, so my answer has to have an uncertainty of plus or minus 100. When I add these together, just using my math skills, whoops, never mind, we're not adding. Let's erase that. We're subtracting. So 30 minus 12900, I get negative, whoops, still on erase. I get negative 9870, which does not have an uncertainty of 100 because its last decimal place is not in the 100 spot. So I need a sig fig here and a sig fig here. The next digit is greater than 5, so I'm going to have to round up, and this will be 9,900 as my answer. In the next example, I gave you some numbers in scientific notation because I want to illustrate that it's a good idea to write these out to determine their uncertainties. So 3.50 times 10 to the third is going to be 3500. Last significant figure is right there. And I'm subtracting 5.12 times 10 to the negative to 10 to the fifth. And I'm just going to write this over here for the moment. 1, 2, 1, 2, 3. And last significant figure is that 2. So 0, 0, 0, 2, 1, 5. There's my number. And we can see uncertainty in this number was that middle 0 is plus or minus 10. The uncertainty in this number is plus or minus 1,000 or 1,000 because my last significant figure is the 2 and it's in the 1,000s place. So I take 3,500 and subtract 512,000, and I get a big negative number. I get negative 508,500. My uncertainty right now is not in the thousands place because my last significant figure is not in the thousands place. So I need this digit and this digit and this digit, and every other digit is going to become a 0. I have to round up because that next digit was a 5. And then I have placeholder zeros so that I make sure I have the number as large as it needs to be.